Today, we'll be talking about pollution legacies within Southeast Ohio. This lesson was originally created by Rebecca Bennett and edited by Mariah Thrush as part of Ohio University's NSF-funded Vote of Knowledge in the Science Classroom. First, what is affecting this stream? Have you seen a stream like this before? Pause the video and take a few minutes to discuss this with your classmates. This stream has been affected by acid mine drainage, causing acid to be released into the stream and an iron precipitate creating the orange color you see. This is a power plant, specifically the Gavin Power Plant in Cheshire, Ohio. Pause the video and take a few minutes to discuss what kind of services and goods power plants provide, as well as problems that power plants create. Power plants provide energy to nearby homes and businesses and can create jobs for local people, but they can be a source of pollution that can cause human and environmental health problems. Pollution is the introduction of contaminants into the natural environment that cause adverse change. Generally, most people think of chemical pollution, like oil spills, but noise, heat, and light can also be sources of pollution. There are two categories for pollution sources, point and non-point. Non-point pollution sources are when pollution is discharged over a wide land area, while point source pollution originates from a single point, like a sewage outflow pipe. It's a good rule that if you can point to it, it's a point source, and if it takes a sweeping gesture to indicate where it is, it's a non-point source. Let's talk about some sources of pollution in Southeast Ohio. Mining has been a significant component of the Appalachian economy for about 200 years. Both abandoned and active mines may cause considerable damage to streams and rivers stretching over thousands of miles. Most of the problems arise from high acidity, sulfate, and various metals such as iron, manganese, and aluminum. Contaminated drainage from abandoned mines is considered to be the most significant non-point source of pollution. A specific type of mining pollution is acid mine drainage. Many streams afflicted by AMD were considered dead just 15 years ago. Prior to the 1977 Surface Mining Control and Reclamation Act, there were no laws mandating reclamation at mining sites in the United States. Decades of coal mining in the early 1900s left behind thousands of scars that no one was responsible for healing. Non-point source pollution of AMD can look like point source pollution. Though we see a single hole producing AMD, a mine rarely has a single entry or exit. There are numerous small holes that could be leaking AMD. Sometimes, the holes are so small that researchers don't initially realize there's AMD pollution at a source. Acid mine drainage is water that has high levels of acidity and dissolved metals, polluted by underground or surface mining. Underground, water and air react with pyrite, a mineral commonly called fool's gold that is found in coal deposits. Through this reaction, sulfuric acid and ferrous hydroxide are created, forming AMD. The sulfuric acid acidifies the stream, degrades the habitat, and decreases a stream's ability to support life. The ferrous hydroxide, called yellow boy, is a fine sediment that coats the entire stream bottom, shading out algae that aquatic insects and fish eat. The picture looks like the water itself is orange, but it's actually the yellow boy coating everything. AMD streams aren't doomed forever. Researchers can reclaim some of the habitat. A success story in Southeast Ohio is Raccoon Creek, which now supports a healthy aquatic community. Treatment aims to improve water chemistry, biological indicators, including fish, macroinvertebrates, and algae, and the physical conditions of the stream. This picture is a lime doser in Raccoon Creek. It doses lime, a base, into the stream to neutralize the acid in the stream. So how does neutralization occur? Dosers help alleviate the problem of acid mine drainage by neutralizing the acid. In the reactant left-hand side of the equation, can you identify which material is the acid and which is the base? Calcium carbonate, the base, combines with the sulfuric acid from acid mine drainage, producing a salt, water, and carbon dioxide. This reaction eliminates acid from the stream. A coal-burning power plant is a point source pollution. Remember, if you can point to the source, like a smokestack, then it's a point source. The Gavin Power Plant is located in Cheshire, Ohio, on the Ohio side of the Ohio River. It's a coal-fired power plant that can burn 25,000 tons of coal to generate 2,600 megawatts of energy when running at full capacity. It is the largest mercury polluter in Ohio and 10th in the nation. Pause the video and discuss why mercury is bad for both humans and the environment. Mercury can cause many health problems in humans, including kidney failure and extreme exposures. Organisms in the environment can also be negatively affected by mercury exposure, sometimes resulting in death. Mercury moves through the environment. We'll break these movements down into 7 steps. The first step is mercury vapor release, either by natural sources like revaporization from water bodies or anthropogenic sources like fossil fuel burning. Once in the atmosphere, the mercury can circulate widely around the globe for up to a year, hence the worldwide dispersion. At some point, the mercury vapor is photochemically oxidized into inorganic mercury that combines with water vapor and falls back to Earth's surface as precipitation. The precipitation falls into soils and bodies of water. In the soil, mercury accumulates with repeated precipitation events until a physical event causes mercury to be released. In water, the inorganic mercury converts into mercury sulfide, which settles out of the water and into the sediment. Alternatively, the inorganic mercury can be converted by bacteria that process sulfate into methylmercury. Bacteria that have consumed mercury is in turn consumed by organisms higher up the food chain. This process is called biomagnification. Mercury is naturally released back into the atmosphere by revaporizing. Mercury can harm us, even kill us, depending on the dose. Gingivitis, mental confusion, memory loss, irritability, swelling or peeling skin, numbness, rashes, upset stomach, and kidney failure are all symptoms from mercury exposure and ingestion. We can limit mercury by putting restrictions on power plants as to how much mercury and other pollution they can emit in a given time. Pause the video and discuss this question. What are we doing to pollute our environment now that will be banned or regulated 10, 20, or 30 years from now? To get you started, think about prescription drugs and water treatment systems, old cars, or drums of toxic wastes.